Hello everyone. So as I discussed in my previous video this morning, the theme of today's lesson was going to be the rust chemical reaction, which I thought was fitting since it was the rust chemical reaction that banished me from my home to my father's front porch for the day. Okay, so let's talk a little bit about rust. As I mentioned in a previous notes video, there's only a few specific elements that exist, only about 100 that exist naturally, and only a few dozen elements that we encounter on a day-to-day basis. But these elements can combine to form millions of different substances that make up the world. One such substance that they form is rust. So here's a bit of rust on my father's front gate. Now, rust is formed from two of those elements. It is formed by iron and oxygen. When oxygen molecules bounce into rust molecules with enough energy, they can combine to form rust. Again, oxygen and iron combine to form rust. Now, normally this is a pretty slow process. For example, here's a bit of steel wool that I left out overnight. You can see in some spots the silvery bluish metal is turning a little bit brown. It's normally a slow process, and the reason is because there's not a lot of oxygen particles floating around in the air. Air is mostly nothing, okay? And even if an oxygen particle impacts an iron atom, it doesn't usually have enough energy to initiate the rust reaction. So let's see if we can speed up the rust reaction in some different ways. And here is the first way. If we can heat up the iron and the oxygen, that will increase the speed that the particles are moving. And so when they collide, they are far more likely to create a chemical reaction. So I'm going to take this iron, the oxygen in the air, and a little bit of heat. Let's see what happens. Okay, here we go. So normally a rusting process that could take hours or an entire night, if I just add some heat to this iron, we can see pretty quickly every place where it starts to glow, we are seeing iron combining with oxygen in the air to form iron oxide, aka rust, okay? And so it takes only a few seconds to complete what would normally take many hours of the day to complete, okay? So that is one way you could stop the rust reaction, by adding heat. Here's another way. As I mentioned before, there is not a lot of oxygen in the air. Air is only made up of about 1/5 oxygen, and even still, air as a gas is mostly empty space with very sparse particles bouncing around. But what I have here is hydrogen peroxide, the same kind you'd get at just your everyday CVS or grocery store. It's a bit more concentrated than the kind that you get. But what hydrogen peroxide is H2O2. Two hydrogens and two oxygens. That formula may sound familiar. You might be like, Mr. Gucci, that sounds just like water, H2O. And it is very similar to water. But whereas water just has two H's and one O, hence H2O, hydrogen peroxide has two H's and two O's, H2O2. So hydrogen peroxide has one extra oxygen atom attached to it, and it's pretty unstable and will detach in specific situations. So what I'm going to do is I'm going to add some hydrogen peroxide to some iron, and we're going to see how long it takes for those concentrated, highly concentrated oxygen atoms to bounce into the iron and cause it to rust. Here we go. Okay. Yes, okay, there we go. So hydrogen peroxide added to the iron. And I'm gonna get a little stirring rod here, and I'm just gonna stir it up a little bit. Here we go. Here we go. Oh my gosh, already you can see in a very short amount of time, the fluid in this beaker is turning a deep brownish red. And that deep brownish red is rust. So almost immediately this stuff is turning into into rust. All right, just smushing it around, smushing it. All right, I think it's gotten mixed up. Now, if we look at it up close, we can actually see that bubbles, yeah, there we go. There are some bubbles starting to form, okay? As the oxygen is released from the hydrogen peroxide and combines immediately with the iron to form rust, all right? Pretty cool. It's actually starting to get kind of hot. You can see steam forming around the outside of the container. Yes, the rust reaction actually releases a lot of heat. You just don't notice it normally because, as I said before, rust happens so slowly that there's never enough heat that you could detect with like just your hands or stuff. We can actually start to see some steam coming off of the top of this. It's getting so hot. Okay, so that's another way to speed up the rust reaction. Add more oxygen. Okay? So that's two ways to speed up the rust reaction, okay? If we add some heat, it causes the atoms to move faster, making it more likely that they'll smash into each other and form rust. Another way to increase the speed of the rust reaction is to increase the amount of oxygen atoms there are. Let's not wait for an atom from the air to come and hit the iron. Let's just expose it to concentrated oxygens by breaking down hydrogen peroxide, okay? And so now, there's a third way to speed up the rust reaction, and that is to do both things simultaneously. What happens if we expose this iron to large quantities of heat and large quantities of oxygen at the same time? And that's where my friend potassium chlorate comes into effect. Okay, potassium chlorate, KCl O3. We'll learn more about what that means later, but essentially it's a potassium atom symbolized by a K, a chlorine atom symbolized by a Cl, and normally those two things can be very stable together, and then 3 oxygens. Now these 3 oxygens attached are not very stable, and it's very easy to break those oxygens off and attach them to something else. So what I've done here is this. I have taken a ball of steel wool and I've incorporated into it a large quantity of potassium chlorate powder. And so when I heat this up, we are going to be exposing this steel wool to both heat and large amounts of oxygen. Let's see what that does. But first things first. You're probably not going to want to breathe this in. Okay, let's see what happens. Potassium chlorate and iron and heat. Okay. Shoo! Nice! And so, to conclude, ladies and gentlemen, that is why I was not allowed to be in my house today. Have a great day.